Hey crew, it's SAT hijackers back at it again, hijacking the SAT one problem at a time. Geometry can be weird, but it doesn't have to be painful. In this video, I'm walking you through real SAT geometry problems and showing you how to break them down step by step. Whether you're feeling confident or completely confused, you leave this video knowing more than you came with. Let's figure it out together. So here we have right triangles element and PQ are similar, where L and M correspond to P and Q respectively. Angle M has a measure of 53 degrees. What is the measure of angle Q? So here we have a triangle problem. So I'm going to draw two triangles to help you guys visualize this problem and label it as well. So the equation states where L and M correspond to P and Q respectively. So based on that information, we can say that L is congruent to P. So angle L is congruent to angle P, and angle M is congruent to angle Q because they correspond to each other. And since we know that angle M has a measure of 53 degrees, we can write M is equal to 53. And therefore, since M is equal to 53 and M is equal to Q, we can say that 53 is equal to Q. Therefore, angle Q is equal to 53 degrees. Therefore, our answer is B. Here we have a rectangle problem. It says the area A in square centimeters of a rectangular cutting board can be represented by the expression W times W plus 9, where W is the width in centimeters of the cutting board, which expression represents the length in centimeters of the cutting board. So here we have a rectangle on our right. It's already been drawn, and I'm going to label it with our area. So we know the area can be written as W times W plus 9 as shown by the equation in the question. So we're going to have W plus W times W plus 9 in the center to represent our area. And then we know area is equal to, we can write this as a variable. So we have area is equal to width, which is W, times W plus 9. So we have width times width plus 9. So we know the formula for area of a rectangle is area is equal to length times width. So we can write that down. So area is equal to length times width. So based on the question, we know that W is the width, as shown in the question right over here. W is the width. So we can say that W times W plus 9 is equal to our area, as that represents our length times width. We can set those two equations to equal to each other, so we get W times W plus 9 is equal to length times width. And we want to solve for W, so we're going to divide both equations by W to get it on one side. So we're going to have length is equal to W plus 9. As you can cancel out the W in the denominator and the numerator. So our answer is D. This is a pretty simple problem if you know the concept of area and how to rearrange two-step equations. So here we have a circle problem. It states circle A has a radius of 3n and circle B has a radius of 129n, where n is a positive constant. The area of circle B is how many times the area of circle A? So I have two circles drawn over here to visualize this problem, and now I'm going to label it. So I'm going to have circle A over here on the left side, which is a smaller circle. We're going to have circle B on the right side, which is going to be the bigger circle. So we know that if we have a radius of 3n as shown in the equation, so we're going to have radius 3n for circle A. We have a radius of 129 for circle B, so we're going to have 129n on circle B. So we know the equation for the area of a circle is area is equal to pi r squared. Area is equal to pi r squared. Therefore, since we know the radius of circle A and circle B we're going to write these two variables down. So we know radius A is equal to 3n and radius B is equal to 129n. So we're gonna put these variables into our equation. So we're gonna have area A is equal to pi times 3n squared. 3n squared. And then we have the formula for area A written out and our variable for radius inputted. We're gonna draw our equation for area B. So we're gonna have area B is equal to pi times 129n squared. Yeah, I forgot to put the n from my previous equation. So you're gonna have 129n squared. So now we can simplify both these equations. So area A, once simplified and distribute the squared, is equal to 9n squared pi. Now we're going to do the same thing for area B. So we're going to do area B is equal to area B is equal to 129 squared, which is 616,641. So and we're going to have our n squared times pi. So now we can put this in a proportion because they have common terms such as n squared and pi, so we don't have to simplify any further as they both have similar terms that are going to cancel out in this proportion. So our proportion is going to be whole over part. So we're going to have AB over a area of A. So area of B over area of A is equal to, now we're going to input our numbers for area B and area A. So we're going to have 16,641 times n squared pi divided by 9n squared pi. So our answer is going to be 1,000. We're going to cancel out our n squared and pi's. So now our answer is going to be 1,849. Therefore, our answer is D. Here we have a triangle problem. Our problem states for the right triangle shown, A equals 4 and B equals 5, which equation represents the value of C. So we have A, B, and C, and we're trying to find C, which is our hypotenuse. So we're going to use Pythagorean theorem, which is the equation we use to find the hypotenuse of a right triangle. We're going to have A squared plus B squared is equal to C squared. So we're going to have C as our hypotenuse, as I just shown. So we're going to have 4 and 5 as our A and B. So now we input that into our equation for Pythagorean theorem. So we're going to have 4 squared plus 5 squared is equal to C squared. Now we want to cancel our square using a square root. So we're going to have square root 4 squared plus 5 squared is equal to C. Therefore, that equation fits answer D, so our answer is D. Here we have a radian problem. It states the measure of angle R is 2 pi over 3 radians. The measure of angle T is 5 pi over 12 radians, greater than the measure of angle R. What is the measure of angle T in degrees? So here we have a radian problem that looks tricky, but is actually very simple. So we know that angle T is equal to angle R plus 5 pi over 12. 5 pi over 12. So therefore, since we know r is equal to 2 pi over 3, we're going to input that into our equation. So t is equal to 2 pi over 3 plus 5 pi over 12. It's 5 pi over 12. And now we want to simplify because these are fractions and we're doing addition and they don't have a common denominator. We're going to multiply the initial fraction by 4 to reach a common denominator of 12 using our greatest common factor. So our GCF is 12, so we're going to multiply 2 pi over 3 by 4. So we're going to get 8 pi over 12 plus 5 pi over 12. And we're going to add those two together as they have a common denominator. So we're going to have 13 pi over 12. So that's the total degrees of angle t. So now we have to convert. This is the total radians of angle t. So now I have to convert this to degrees. So degrees is equal to 13 pi over 12. So we want to convert this to degrees. So we're going to use 180 over pi. That's what we use to convert to degrees. That's the ratio. That's the proportion you use to convert from radians to degrees. So we're going to have times 180 pi. So pi degrees is equal to, you cancel out the pi on both sides. So you're going to have 13 times 180 divided by 12. And now we simplify even further. So now, once we've simplified, we have 2340 divided by 12 is equal to our degrees. Simplify even further, our degrees is equal to 195. 195. Therefore, our answer is C. Pretty simple question.